Hello everyone, my name is Golara Javadi and I'm an applied scientist at Explain. Today I want to talk about our paper word level ASR quality estimation using NoRefer for efficient corpus sampling and post-editing. For enhancing automatic speech recognition systems, there are usually a couple of challenges. First of all, these days there is a need for explainability in this system, and mainly when we are dealing with commercial ASR models that often operate as black box, and these complex models deliver high accuracy, but usually they lack in transparency in their decision-making process. The other challenge is the evaluation of these systems. Traditional evaluation of ASR systems rely heavily on reference-based metrics like word error rate, which require ground truth transcriptions that are time-consuming and mostly costly to obtain. So in our project, we explore the utility of token or word attentions of a reference-less metric for explainable AI in ASR systems. And here we use NoRefer method as a reference-less metric, but our approach can be extended to any other model-based reference-less metric. So this technique can assist post-editors and improve ASR system quality through refining the output and corpus building. And also this can have an application in enabling error identification and enhancing transparency without confidence score for commercial or any black box models. So basically our motivation here is to analyze the attention score at different levels. Starting with the sentence level, with the use of NoRefer, we already calculated the sentence level score, and we can examine which sentence have higher or lower score and compare these with their respective word error rate value. And sentences with the higher word error rate might be expected to have lower model confidence score and vice versa. On the word level, for this, we need to calculate the average attention score for each word and comparing these scores with the edits that are required in the transcription. We expect that words which require more edits or correction might correlate with higher attention score. On the token level, this is very similar to the word level analysis, but with more granular, and it can be particularly insightful or for understanding how the model treats the subwords or part of the words, especially in cases where edits occur within the word. So for the reference-free quality metric, we use NoRefer, which is one of our previous works that we published last year. I don't want to dive deep into the details of the model. Here you can see the GitHub page. I encourage you to go to this GitHub page and explore the details. But in general, NoRefer is a multi-language reference-free quality metric for ASR systems, which overcomes the limitation of traditional reference-based metrics, and it is especially useful for speech datasets that lacking the ground truth, and the fine-tuned model demonstrates a high correlation with word error rate, scores, and ranks. So our study focused on analyzing the attention distribution of the reference-free quality model, which here is NoRefer, and we check its behavior at both word and token level across sentence with different word error rates. The attention scores from the model's layer are basically first collected, and then we average them across all the layers and heads, and then refined by scaling with the L2 normal value vector to improve the interpretability and reliability in identifying the word level errors. So for evaluation of our method, we use AUC, average precision, and top K classification metrics. And as a reference, attention values are compared with the binary score from the GWare library, which label faulty words in the transcription, such as those that are deleted, inserted, or substituted. You can also see the stats of our dataset from LibreSpeech, Common Voice, and also all datasets combined. So using max pooling and attention is scaled by the norm of value vectors as a chosen method for aggregation of attention scores. The metrics are calculated to evaluate the attention score as a quality estimation measure. And when selecting the optimum value for K in top K classification metrics, we use two different methods. One, we fix the K to a constant value, and second one, we adapt a dynamic approach where K is set to 10% of each sentence length. As a baseline for this evaluation, we use the confidence scores from publicly available ASR models, including Whisper and CTC, and also we use a random approach. We combine all the datasets and calculate these metrics for our method and also the baselines. And when comparing these values, we can tell the results from our method is actually better. For the evaluation study, we used two strategies for understanding the model behavior. One was the scaling, and the other one was the aggregation of the tokens. On the scaling, we compared the raw attention values with the attention scale by the norm of value vectors, or multiplying them by the gradient. And we find out the attention values that are scaled by the norm of value vector give us a deeper insight into how model weights prioritize the different token and words in a sentence. And in the transition from the token level to word level attention, we used three different aggregation methods. One was average attention, which calculates the mean of all token scores for each word. The other one was the max attention, which identifies the highest attention score in the word token. And the last one was Q3 attention, which focuses on the third quantile value among all the tokens. And we find out the max attention values actually give us a better results. So we choose max pooling and attention scale by the norm of value vectors as the chosen method. In conclusion, we can tell that our model helps us with the explainability of the ASR systems, and it can give us a roadmap for targeted improvements by refining the model training and data augmentation strategy. And this can be done by just showing where the error comes in a sentence without listening to the entire voice or speech before the translation. Finally, I want to thank you for listening to this talk, and please follow us on our GitHub page for more detail.